Hi everyone. So we are going to solve GFG POTD. So today's problem is count pairs divisible by k. So here we have an array and a positive integer k. Okay, we have an array and a positive integer k. We have to find the total number of pairs in the array whose sum is divisible by k. So if we take an example, like the first example, like array is 2, 2, 1, 7, 5, 3, and k equal to 4. If we see this two make 4, this is a solution. This 2 plus 1 is 3, not divisible by 4. It would not be counted. 7 plus 1, 8 divisible by 4, so it is valid. 5 plus 3, 8 divisible by 4, it is valid. So, okay, so we have to count all that valid pairs. Pairs means we can take any two number and we will add if it is divisible by k or here it is divisible by 4. So are going to increase our count and we have to return the count. Okay, so now let's see how we can go for it. See, now if we see I have written two examples from that from GFG itself. Okay. So now what is the thing that comes in our mind initially? So now if we see like if take 221753 as this in these questions, what we can see if we keep two pointer like I mean like if we fix this pointer like see and we move like next 2 plus 2, what is that? 4 divisible by 4, that is 1. We have answer 1 plus now 2 plus 1, 2 plus 1, is it valid? No. Okay, so it is not valid. Now 2 plus 7, is it valid? No. 2 plus 5, 7 not. 2 plus 3, uh 2 plus 3, 5 not. Now now for this 3 also, for this 2 also, 2 plus 1, 3 not. 2 plus 7, 9 not. 2 plus 5, uh 7 not. 2 plus 3, 5 not. Okay, now if we take 1, so 1 plus 7, 8 divisible by 4. So it will give solution. One solution. 1 plus 5, 6 not divisible. 1 plus 3, 4. Okay, so this is 1 plus 3, 4 divisible by 4. So it gives one solution, right? Now, if we take this 7, 7 plus 5 is 12 divisible by 4, right? 7 plus 3, 10 not. Now, if we take this 5, 5 plus 3, 8 divisible by 4. So no. Then this 3, we do not have any number. So if we add this 5 solution, this is also there now. But but if we see like we have to fix at that means we have to fix our one pointer and move another pointer to the complete, and similarly this thing. So okay, so this is I and the moving pointer is here, then it is going to, that means if array's length is n, so first it would be n, and another is also going to cover all the arrays. So it is basically going to take the complexity of n square. And if we see the constant, which is 5 into 10 to the power 5. Okay, so due to n square, it becomes around 25 into 10 to the power 10, right? Something. So it is not going to pass the test, uh, all test cases. So how we can solve this? Okay, now, okay. So now what we can do? So now the first thing that came in my mind is like, can't we try to sum array? So if we see to sum array, what is the things we do in the to sum? We have one number and the second number we find in the map, okay? And whether we are going to check whether this is target or not, right? We are going to find two number and check if it is target or not. But if we see here that we do not know that exact target, because if k is suppose 4, so our target can be 4, 8, 12, even 0, so it is divisible by k. So we do not know what can be the sum. So we can't efficiently find all the things in the map, right? So to avoid this, what if we can do some things with this target? Okay, so from this the solution came. Now see what we can do. Now what if we take the modulus of this array? Modulus with what? with k. So this becomes 2, 2, 1. This becomes 7 modulus 4 is 3. This becomes 1. This is 3. Now, now see, as we say that two divisible, what should be the pair sum? It should be either 0, k, 2k, 3k, something like that. So that it will be divisible by k, right? Now, as we take the modulus, what would be any, if we take any array of I, what can be this value? This can be 0 to k minus 1, not even the k, right? Because we are taking the models. Now, if we take a suppose array of I and another is array of Z, that means this two index, any two index. So this would be also from 0 to k minus 1. What can be the maximum sum of 82 number we pick from the array after taking the modulus? So it is 2k minus 2. Okay. So what is this less than 2k? Right. So now one thing we know that whatever our target was, initially our target was large. Now our target is less than 2. Now, one more thing we know, our target should be in the range of, should be in this one, either 0k, 2k, 3k something. So if we see, if we put this condition here, right? So what we get? So we get either 0 or k. That means either the target cannot be 0 or k, or we can say the sum could be either 0 or now. See how we can. Okay. Okay. So now we are just going to write the same code of to sum, but we have now two target. One is 0 and one other is k. Now, see, so what we do, we will keep one map, right? Okay. Now if we see, okay. Now first things, first here we are here, right? So now what is target? Target is 4. To reach the target 4, what we have to do? 4 minus 2, which is 2. And to reach 0, what we have to do? 0 minus 2, which is minus 2. Right? Now, neither we have 2, neither we have minus 2. Right? So we do not have any solution now. Now what we do? We will put this in map. So 2 first time, so its occurrence is 1. Now, now we move to this. Right? So if we are here, what we say? 4 minus 2 again 2, and this is minus 2. Now we have occurrence of 2, right, at one time, so we have one solution, right? Okay. Now, now we will increase its occurrence to 2, right? Now we are at here 1. So if we say 1, 4 minus 1 is 3, and 0 minus 1 is minus 1. Do any occurrence of 3 is there? No, minus is not there. So, okay, we will move by putting this in the map, right? Okay. Now, what next is 3. So, for 3 to 4 minus 3 equal to 1, and 0 minus 3 equal to minus 3. So if we check any occurrence of 1 is there, yes, occurrence of 1 is there, so it will put in the answer, and we are going to put this in the map as well, right? Now, what if we see now next is 1? If we see the 1, okay, so to reach the 4, it need 3, or to reach 0, it need minus 1. So any occurrence of 3 is there? Yeah, that is one occurrence of 3 is there, so we will put add 1, okay, and now we will increase the occurrence of 1, so this become 2. What at last is 3. So now to reach 4 to 4 minus 3 equal to 1, and 0 minus 3 is minus 3, right? Now if we see how many occurrence of minus 3 is there, no, occurrence of 1 is 2, so 2 more solution will be added. So what would be that is total? That is total 5 solution. Now see, okay, now one thing should come in your mind, that if we see we are always getting one negative value, okay, and it is of no use because in our question is given like array of I, okay, is not negative, right? Now, but why we are putting things like 0 minus 2? Because what if array of I is 0? That is because we have put the modulus, so array of I can be 0. So if array of I is 0, the one is k minus 0, which is k, and another is 0 minus 0 is 0. Now, as we said, after modulus, it could be 0 to k minus 1. This is not valid. In that scenario, this is valid. Okay. So for that, we are doing these things. Okay. Now, if we see, like, okay, now Now I think things are clear. Now I will write code and we see like any more confusion is coming in our mind or not. Okay, so let's see the code. Okay, now first thing what the first we need to do. The first thing that we need to do is we have to put all the element of array by reducing as of modulus like int I equal to 0, I less than n, and I plus plus we will declare n. Okay, okay, dot size, right? Okay, now what we do, array of I equal to array of I modulus k, right? Now, now, now the next thing is we know we are going to decrease from 0 and k. So we have two remainder. That means we have two remaining number which I need to find in map. Okay. So int I equal to 0, I list them again, same things. Okay. Okay. Before this, uh, so before this we will make one map. Okay. Map or we can take another map anything. Into okay. Now what we can do? We will put MP of okay, we will put later, but first we will find out like what are the two number that we are going to find in the map. So int remaining one equal to now what? So remaining one is k minus array, right? So what will be the remaining two? So int remaining two equal to 0 minus array of I, right? Now we now see there might be some occurrence of this or as well as this or if we see like okay, so we will put int generally only one would be there, so int count equal to 0, right? Okay, why I said like generally one, generally means why only one, because in one case it will be negative which will not be feasible with c, as we say array of I is a positive number. Okay, and another in case of 0, that key can't be there. One is at 0, one is 0 minus 0 is 0, one is k minus 0 is k, k can't be there because 0 to k minus value can only be there after the modulus, so only one of this would be done. Okay, so now if mp dot find find remaining number one, if this is there, it is not equal to empty dot, if this is there, what we are going to put count to count plus equal to no MP of remainder one, right? Now, similar things we are going to do with the remaining, we can say remaining remainder, which is whatever remaining two. Okay, okay. Now take they take some one variable return like int result equal to 0. Okay, and we are going to add this in result. Result plus equal to nums of sorry result plus equal to cnt count. Okay, now one last thing is there which we have to put that occurrence of the number in the array, that is array of I, that is we are going to increase the count array of I, right? Now we have to return this result, right? Let's run. Hmm, okay, so these things we have to here. Okay. See, what more things if you want to remove this line of codes or extra no, as we know like in the loop we are only using the in a loop we are only using that proper array of I only if you see, so we are not going to see any future values, okay, or any past one. So if even this time also we change, we do not have any issue, so we can remove this extra line. Okay, and we try to submit the code. Okay, so it got passed. Okay, so thank you for the watching.